The centipede does not announce its presence. It does not roar, it does not display bright warning colors in open daylight, and it does not seek attention. It exists in the quiet margins of the world, beneath stones, inside rotting wood, deep within soil that rarely feels the warmth of the sun. When the earth cools and shadows lengthen, the centipede begins to move, its many legs flowing in coordinated waves, carrying an ancient predator through a landscape it has ruled for hundreds of millions of years. Long before mammals walked the land, before birds filled the skies, before flowering plants reshaped the surface of the planet, centipedes were already here. Fossil evidence places their ancestors among the earliest arthropods to colonize land, emerging during a time when Earth's surface was harsh, unstable, and largely uninhabited. Oxygen levels were different, climates were extreme, and survival demanded adaptability above all else. In this world, the centipede evolved not as a passive scavenger, but as an active hunter, shaping its body and behavior around speed, venom, and sensory precision. The centipede's body is long, segmented, and unmistakably purposeful. Each segment carries a single pair of legs, a defining feature that separates centipedes from their slower, plant-eating relatives. These legs are not identical, those of the front serve different roles than those of the rear, contributing to balance, grip, and propulsion. The final pair often extends backward like antennae, confusing predators about which end is which, a simple illusion that can mean the difference between life and death. At the head lies the centipede's most formidable adaptation, the forcipules. These are not jaws in the traditional sense, but modified legs that have evolved into venom-injecting claws. Connected to venom glands, they allow the centipede to seize prey and deliver a precise, often paralyzing dose of toxins. This venom varies widely between species, ranging from mild compounds effective against insects to powerful neurotoxins capable of incapacitating animals far larger than the centipede itself. In the largest species, a bite can cause intense pain in humans, a reminder that size alone does not define danger in the natural world. Vision plays only a minor role in the centipede's perception of its surroundings. Many species possess simple eyes, capable of detecting light and shadow but offering little detail. Instead, the centipede relies on a network of sensory hairs and antennae that constantly sample the environment. These structures detect vibrations in the ground, changes in air movement, and chemical traces left by potential prey. To a centipede, the soil is alive with information, each tremor and scent forming a map of opportunities and threats. Movement is where the centipede truly excels. Its legs move in a coordinated rhythm that allows rapid acceleration and sudden changes in direction. Unlike insects that rely on predictable patterns, the centipede's motion appears almost fluid, its body bending and flexing to navigate narrow spaces and uneven terrain. This agility makes it exceptionally difficult for prey to escape once detected. Even in complete darkness, the centipede hunts with confidence, guided by senses refined through deep evolutionary time. Hunting is a solitary act. The centipede does not cooperate, does not communicate with others of its kind, and does not share territory willingly. Each individual claims a hidden domain beneath rocks, logs, or soil, emerging primarily at night to patrol its surroundings. When prey is encountered, there is no hesitation. The centipede lunges forward, forcipules striking with accuracy, venom flowing instantly. Smaller animals are subdued within seconds, while larger prey may struggle briefly before succumbing to paralysis. The venom itself is a complex chemical cocktail. It may include neurotoxins that disrupt nerve signaling, enzymes that break down tissue, and compounds that prevent blood clotting. This combination ensures not only the rapid immobilization of prey, but also the beginning of digestion before feeding even starts. Once the prey is secure, the centipede uses its mandibles to tear flesh into manageable pieces, consuming nutrients efficiently in an environment where meals are unpredictable. Despite its effectiveness as a predator, the centipede is not invincible. Birds, reptiles, amphibians, and mammals all prey on centipedes when given the opportunity. To survive, the centipede relies on secrecy rather than confrontation. Its flattened body allows it to squeeze into impossibly tight spaces, vanishing into cracks and soil where larger animals cannot follow. In some species, legs can be shed to escape a predator's grasp, a sacrifice that allows the centipede to live another day and regenerate lost limbs over time. Reproduction is a quiet, almost ritualistic process. Males deposit spermatophores, which females later collect, avoiding direct mating contact in many species. Eggs are laid in protected chambers within soil or rotting wood, and in a rare display of arthropod parental care, some centipede mothers guard their eggs and young, coiling around them to provide protection. This vigilance continues until the juveniles are capable of surviving alone, after which the bond is broken and each individual begins its solitary existence. Centipedes grow through a series of molds, shedding their exoskeleton to accommodate increasing size. With each mold, they become faster, stronger, and more efficient hunters. Unlike insects that undergo dramatic metamorphosis, the centipede's development is gradual, a steady refinement of form rather than a transformation. This slow progression mirrors their ancient lineage, unchanged in its core design for vast stretches of geological time. Ecologically, centipedes play a critical role in controlling populations of insects and other small invertebrates. By preying on species that might otherwise multiply unchecked, they help maintain balance within soil ecosystems. Their presence is often a sign of healthy, undisturbed environments where organic matter supports diverse life. Remove the centipede, and the ripple effects can alter the delicate equilibrium beneath our feet. Human perception of centipedes has long been shaped by fear and misunderstanding. Their many legs, rapid movement, and venomous bite have made them symbols of danger in folklore and popular culture. Yet serious harm to humans is rare, and most encounters result only in brief pain rather than lasting injury. In reality, centipedes prefer avoidance, retreating when possible rather than attacking unprovoked. Scientific interest in centipedes has grown steadily in recent years. Their venom is being studied for potential medical applications, including pain management and antimicrobial treatments. Their locomotion inspires research into robotics, particularly machines designed to navigate complex terrain. Even their sensory systems offer insight into how simple neural networks can process information efficiently, without the need for large brains. As night deepens and the surface world grows still, the centipede continues its silent patrol. It does not seek dominance, recognition, or conquest. Its success lies in precision, patience, and adaptation, qualities forged through survival in environments that change slowly but relentlessly. The centipede endures not because it is feared, but because it is perfectly suited to the shadows it inhabits. In the hidden layers of the earth, where roots intertwine and decay feeds new life, the centipede remains a constant presence. An ancient hunter, unchanged in purpose if not in form, moving through darkness with the confidence of a creature that has seen worlds rise and fall. Long after the noise of the surface fades, the centipede will still be there, following the quiet rhythms of the soil, a reminder that evolution favors not the loudest or the largest, but the most adaptable.